Welcome to the Stormsurf video surf forecast for the week starting Friday, February 22nd. We're getting significant wave heights for the North Pacific Ocean. We see wind swell pushing down the California coast. Some sort of swell pushing in, 20-foot seas, pushing into British Columbia, northern British Columbia. Another area of 20-foot seas over the North Dateline region. And actually, a typhoon, if you can believe it, in the far West Pacific. Kind of unusual. All right, let's get into the details. We'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough that is a dip in the jet, and there's kind of one right there off of Kamchatka, but not really well formed, not dug out, not great for supporting gale development. But if it were, it would help create a counterclockwise flow aloft and also down at the surface. That's the hallmark of low pressure. Low pressure, of course, generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. All right, so the jet's looking pretty good. And yes, we do have our jet stream models and a lot of our weather models back up and running after a couple-week break there. We've managed to work out some of the technical challenges, not all of them, so not everything's running, but the main stuff is up and functional. So the jet is pushing off Japan with winds at 150 knots. Not particularly strong, especially given what's going on with the MJO down here. We thought it'd be a lot stronger, a lot more consolidated, but not horrible. Pushing off to and reaching about to the dateline. And then we have, just as we've seen, this giant split in the jet, with the northern branch pushing up into the Bering Sea and then down through the northeastern Gulf of Alaska and basically into the Pacific Northwest with this semi-stationary trough sitting over Nevada. Southern branch of the jet running over Hawaii and down into Baja. Between the split jet stream, you just get massive high pressure. Of course, that in the northern hemisphere circulates clockwise, generating north winds pushing down the coast. And that's what's been making our wind swell. Let's put this into motion. Now, this model still is having some issues. Kind of every other run it seems to work, and unfortunately we got a bad one here, so it only goes out about 90 hours. But you see the jet sort of continues to do the split thing, but progressively less split, though winds start fading off Japan as we get into Sunday. And there's still the split, but it looks like it just wants to push and totally cut off this northern stream that's off here as we get into Monday or so. And it actually kind of does there for a little bit. And the thought is at some point there's going to be a trough that's going to, and this guy's going to start fading right about there. But you can actually see trough in the upper atmosphere, and that digs out. Still there's this split thing, and the big low pressure is up here, and that just sort of continues on and then meanders about a week out. So not significant relief indicated. But let's go take a look down at the surface. Here's our tropical system, of course, that we saw. That's being generated by strong westerly wind burst that's in pretty much this whole area. This guy has actually been around here for a couple of days, working his way off to the west. Here's our low pressure trough or low surface low associated with an upper level trough there, and then the big split here supporting high pressure. So we'll just roll this out. Now the interesting part is, as we get into Saturday night, theoretically, a pretty solid storm is to develop with 55-knot winds pushing off Japan this Saturday night into Sunday. 60-knot northwest winds, but the issue is, watch this guy. He's moving fast to the northeast. There he looks pretty good about midday Sunday into Sunday night. Next thing you know, he's heading for the Bering Sea as you get into Monday, and he's all but gone. High pressure building right underneath. And what's that do? Starts clocking the winds north relative to Hawaii. Doesn't make it into the U.S. West Coast, though, because there's this sort of trough thing that we expect to start developing. Another low following the same path. Remember, the jet's still split, but it goes right to the Bering Sea, gets no traction. And then where are we at? We're at Thursday, and here comes this low, almost a cutoff low, not quite, pushing towards the U.S. West Coast. Not really going to generate anything but a bunch of south winds and a mess, and then another system off the Kurils. So one solid system indicated and a bunch of wind swell still. Let's go take a look at the wave models, though. That'll help give us a better sense of what these winds' effect will be on the ocean surface. Here we go. Significant wave heights to the North Pacific Ocean. We've gone through the layout here. This is the main system of interest, Saturday night, building with, 49-foot seas approaching the dateline Sunday morning, peaking out probably somewhere right around there, 50-foot seas supposedly. Oh, wait, that's associated with this guy, and that's not right. So, what do we got? Oh, we're just eyeballing this here. Maybe 46, 47-foot seas. About 47-foot seas on the dateline, aim east. That will definitely create swell, pushing both towards Hawaii and the U.S. West Coast. The real issue, and more, look at that. And it actually sort of regenerates back to, say, 47, maybe 48 feet on Sunday night, and then fading out on Monday. You can literally see the swell front pushing towards Hawaii and the U.S. West Coast, arriving on Wednesday in Hawaii, and maybe 2 days after that into, there you go. You can actually see it. It started moving in on like Thursday night, Friday, the U.S. West Coast, and then everything kind of goes a little bit quiet after that. So basically one major swell event for the next week. So let's go take a look at local winds. Right now, winds, not horrible for Hawaii. Still northeast, but not bad. Very light, sort of a dead air pattern right here in between. Northwest winds off the U.S. West Coast, 15 knots, but that's certainly better than it has been. So we get into Saturday, light wind regime in most locales, though starting to turn north for Hawaii as we get into Saturday night. And into Sunday, northeast flow, not strong, 10, maybe 15 knots for the Hawaiian Islands. And okay for Central California and Southern California, but south winds start building ahead of a series of, we'll say, modest to moderate weather systems pushing into mainly the Pacific Northwest. And then we go into Monday. Northeast winds continue for the Hawaiian Islands. South winds for northern and central California. It looks like maybe some rain, too. We'll get into that in a minute. Northeast winds continue into Tuesday. Southwest winds as well for California. Wednesday, there's a pretty good solid north wind event setting up in sync with the arrival of the swell to the Hawaiian Islands. Doesn't look good. Pretty much a blown out mess, and just messy conditions look from north of Point Conception as well. So we get into Thursday, probably wind swell here for the Hawaiian Islands, but bad conditions. Anyway, going into Friday, still just no real relief, and then the south wind event starts for California next weekend, and maybe things back off a little for Hawaii and a little local swell. So not a whole lot. Let's go take a look at precipitation. All right, here we go. Starting Friday night, and we're mainly looking at California. We're mainly looking at snow. We see rain and snow moving in Northern California Saturday night, not really getting into Tahoe. Rain again for Northern California, northern end of the state, and really Oregon, and in from there is where all this is going to be focused for the weekend into next week. Now we get rain Monday night down into San Francisco or so, maybe down to Monterey Bay. And Tuesday, more of the same. Looks like snow possibly for Tahoe, just the north end of it, and then down into Mammoth perhaps by Tuesday night into Wednesday. A little dump there, and rain and more snow as we get into Thursday, and then that backs off. Now this system, a lot of tropical energy associated with it, probably higher snow levels would be the guess as we get into next weekend. So the midweek event looks like the main snow event for Tahoe and the Sierra. Then a quick look at Typhoon Wutip, I guess that's how you say that, in the far west Pacific. You can see it started several days ago. Right now, positioned, we'll say south of Guam. What is that? 3 degrees, so about 180 miles south of Guam. Winds, sustained winds 105 knots. That's like about 115 miles an hour. And expected to slowly fade while tracking north-northwest over cooler waters and dissipate. It is not unusual when you get a strong westerly wind burst, especially in the fall, to get a series of tropical systems developing from those westerly wind bursts. We'll get into that in a second. But to have this happen in, February? That's a little bit of a testament to the strength of the westerly wind burst. And that sets us up for the long-term outlook. What's going on with the MJO and, of course, El Nino? Okay, and westerly wind bursts are a key component of El Nino. So as usual, we like to look at winds across the equator. From the East Pacific here to the West Pacific there. There's the equator. There's New Guinea there. These winds, just looking at the arrows here, are from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. You can see winds from the east, trades, pretty normal this time of year, making it to about 170 west, and then turning either north or actually turning west and pretty brisk. They were actually harder a couple of days ago in the Kelvin wave generation area. That's this area from 170 west to about 135 east, right in there, 5 degrees north and south of the equator. When you get west winds in there, that helps create Kelvin waves, and Kelvin waves are a key component of developing El Nino. They take warm water here in the west, push it to the east underneath the equator down 150 meters. Eventually that water reaches off of Ecuador, erupts along the South American coast, and forms a warm water slick on the ocean surface off of Ecuador. And that, if you get successive Kelvin waves and the warm water stays there long enough, that's what starts off El Nino. All right, so, but it's not the actual winds, it's the anomalies, differences from normal for this time of year. And you see in the East Pacific, winds look pretty much normal, but those westerly winds there, they're much stronger than normal. So this is basically considered westerly anomalies with actual west winds. That's a westerly wind burst, and that is occurring, and that theoretically should help build another Kelvin wave. We can get a sense of what's been going on the past 5 days. So here's 850 millibar winds. That's a fancy way of saying winds up about 4,000 feet, which is a pretty good proxy for what's going on down at the surface. The equator, 0 degrees right there. There's South America. There's Australia, New Guinea, Kelvin wave generation area. When you see west winds right in this area, right there. And these, see, look at the arrows, the reds, that means westerly anomalies. So that's a good solid Kelvin wave, and it was on the 16th, the 17th, the 18th, the 19th, the 20th. Still going on today, though a little weaker. You can see it was definitely stronger back about 5 or 6 days ago. And then we can look at the forecast and the hindcast as well. So this is same thing, 850 millibar zonal wind anomalies for the whole planet, right? 0 degrees is here. 360 is here. The date line is on 180, right? So the Kelvin wave generation area is between these two tick marks, and you just go right up there. The Pacific Ocean goes basically from 120 to about 90 here, something like that. But it's the Kelvin wave generation area we're interested in, because Kelvin waves help feed El Nino. They also feed energy into the jet stream. The active phase of the MJO, if you get westerly winds, like right here. See, the reds and oranges are westerly wind anomalies, and that they've been occurring in the Kelvin wave generation area since late January. They kind of backed off. Then they got much stronger as we got into around Valentine's Day, and are continuing right about to this day. Maybe we'll get another 3 or 4 days out of it, and then things will back off. But that's a pretty solid, as far as Kelvin wave goes, or westerly wind bursts, that's about as good as you're going to ask for. But notice, even from February 22nd on through the end of the month, still westerly winds prevailing in the Kelvin wave generation area. That's a good sign, just like they have been. I mean, it smells like El Nino, but we're not quite there yet. Even though NOAA is officially, sort of throwing their hands up, go, okay, we're in a minimal El Nino, but it's a bare minimal at best. All right, so let's take a look and see what's the MJO going to do long term, out 2 weeks. 15 days, okay? So the blue, this is a outgoing long-wave radiation chart, basically a forecast chart showing you how much sunlight reflectivity off the ocean surface we're going to have, and that's a good proxy for the MJO. The blues are less sunlight reflectivity, meaning clouds, meaning low pressure, meaning the active phase of the MJO. Reds, exact opposite, high pressure, a lot of sunlight reflectivity, the inactive phase. All right, so the active phase is basically on the date line, just barely out of it. And per this, the statistical model is supposed to be fading over the next 5 days and gone, as the inactive phase a week from now sets up in the West Pacific and holds, if not builds a little bit. The dynamic model, there, we'll show you both here, a little bit different. It's saying the active phase also fading, maybe lingering a little bit longer, 5 days out, and then fading out. But the inactive phase, not nearly as strong and very weak moving into the Kelvin wave generation area 2 weeks out. But in either case, inactive phase, and what that means is a week and a half, 2 weeks from now, the jet stream is going to start weakening, everything's going to fall apart. And if one were to guess, we would say a definite start to the springtime pattern about that time. Phase diagram charts. Basically, this is another way for measuring the strength and the position of the active phase of the MJO. And this is like the leading edge of the active phase of the MJO. All right, so assume you're looking down on the North Pole, looking down from the top of our planet, and the equator is like, it runs around like this, and the active phase and the inactive phase move from west to east, from the Indian Ocean to the Maritime Continent, over the West Pacific, across the Pacific, under the United States on the equator, across the Atlantic on the equator, into North Africa, and back to the Indian Ocean. The heavy dot is where the active phase is right now. The further away it is from this circle, the stronger it is. So a moderately strong active phase of the MJO, we'd say in the far East Atlantic, approaching North Africa. And the forecast is 3 different models, 3 different statistical models suggesting, yeah, it moving into the Indian Ocean. 1 strong, 1 weak, probably somewhere in the middle. The GEFS model, dynamic model, says basically the same thing. No change. So basically, wherever the active phase is, the inactive phase is exactly opposite that. So 2 weeks from now, the inactive phase will be smack dab in the center of the West Pacific. And in terms of swell production, storm production, things should really back off. Upper level model, same sort of deal. The greens are areas favorable for precipitation. The orange is not favorable. Not a complete direct correlation, but you can see, so this is South America. It looks like the active phase fading out as we get into about March 4th. Inactive phase building in the West Pacific. Interesting part about this is it just dies. It doesn't really even fully push in. I mean, a piece of it pushes in to Central America about March 24th, but at that time, a new active phase starts building, according to this model, pretty strong as we get into mid to late March and making it to the Central Pacific about April 30th. So maybe a late season push of some storm and gale activity, if one is to believe the model. And then the trusty CFS forecast, same sort of deal, whole planet on one chart, Kelvin wave generation area between these 2 tick marks. Past history up to the top, you can actually see the tropical systems associated with the solid black line is the active phase of the MJO. The dotted line, inactive phase. Every time you have an active phase, look at that, you get tropical activity. Anyway, so here we are, active phase of the MJO. There's a tropical system, and the dark reds, well, you can see it here back in February, pretty strong westerly wind burst, much stronger here associated with this one that's going on right now, and expected to continue for a week and a half or so, and then things slacken off. Still, westerly anomalies, no easterly anomalies in the Kelvin wave generation area. That smells very much like an El Nino-like situation. And then the long-running CFS model goes out 3 months. So this is past history on the bottom, future history. You can go back 3 months. You see there's been no westerly anomalies, anything close to what is happening right now. Again, there's the Kelvin wave generation area between those 2 tick marks. And if you believe this model and you look out into the April-May time things are looking very dynamic, very healthy. Don't believe it, but it looks pretty interesting. Let's overlay the MJO. Here we go. Solid contour, active phase of the MJO. So here's our active phase of the MJO making its way across the Pacific. Still pretty much focused on the dateline right now and into the East Pacific. But by about March 4th or so, it pretty much dies out. The dotted contour, inactive phase of the MJO. And it does its thing from, let's say, pretty much the whole month of March. And then this long-running active phase of the MJO sets up, kind of weak. You know, when you have a weak, so notice there was strong active phase right around in here and inactive. Then as you get further, it gets weaker and weaker. So when El Nino develops, you get weaker MJO signal because the El Nino pretty much acts like a long-running active phase of the MJO. All right? So if I was looking at this, I go, El Nino may be building here, but it looks like it was pretty weak around in here. But then looking at the MJO, it was pretty weak here, so maybe El Nino was strong here. So let's overlay the low-pass filter. And bam, there you go. Okay, so what do we see? So the low-pass filter is an area, basically it's showing an area biased towards low pressure over the dateline with high pressure biased over the Indian Ocean. This is typical El Nino setup. When the reverse is true, when the high pressure is over the dateline, that's La Nina. And when the low pressure is in the Indian Ocean, and during those times, you want to go to the Indian Ocean because that's where all the surf is. Follow the low pressure. All right, so back in the fall, we had 3 contour lines. And then El Nino kind of it just hiccuped and kind of really backed off. The MJO woke up. You can see it here. And then the low pressure bias recently has started to wake up again. And all of a sudden, you see the MJO starting to fade, not as many contour lines. And the cool thing here is so the models have been somewhere in April, May, they're not sure when, but they're showing now 4 contour lines. That's way stronger than we ever had anything last year. To me, that suggests that maybe that's the start of a legit El Nino, maybe in the April-May time frame. So we're moving into what they call the spring unpredictability barrier. The models have a real hard time from March, April, May time frame, spring, because typically that's when El Ninos start to develop. If they're pretty strong, you'll see a clear sign in February, which is kind of almost what we think is going on. And then it'll become real apparent as you get into April and May. And then it just rages the whole way through summer into the fall and builds slowly. So El Nino takes months to build. It's not like an instantaneous kind of thing. You can see the underpinnings of it or see signs of it as early as 9 months before it ever actually, does its thing atmospherically. So this is the time of year we really want to look. And we're seeing definite signs. We're actually almost kind of hoping El Nino doesn't form, but we just go into this long-running, low-pressure bias thing for a couple of years rather than having a big El Nino, because you know the drill. After El Nino, you end up in La Nina, and then you really pay the price. So we'll see what happens, but the models are kind of hinting at something stronger developing in 2019 El Nino-wise than what happened in 2018. All right, enough of that. Let's go take a look what's going on in the ocean now, because there's a subsurface and a surface oceanic component to El Nino, and the MJO as well. Okay, so West Pacific here, East Pacific here. This data from the TAO buoy array. The X's, you know the drill, we've been through this, are the anchor lines. The X's are the sensors on the anchor lines of the TAO buoy array, strung across the equator, 2 degrees north, 2 degrees south. And the data from them helps, with use of a model, helps build you a profile of what the subsurface ocean temperature looks like across the Pacific. And of course, warm water in the west, driven there by constant easterly trades pushing warm water to the east or to the west. But we see the 28 degree isotherm at about 162 west, which is about the same as it was last week. If you have a Kelvin wave, you'd start seeing these lines over time pushing off to the east. We're not seeing that really right now. 24 degree isotherm line pushing into Ecuador about the way it's been. But it's the anomalies, differences from normal for this time of year. And we see, yes, warm water pushing from the West Pacific was at 2-3 degrees. So a small Kelvin wave here south of Hawaii, trying to push off to the east. This negative 2 degree anomalies off of Ecuador is the last of the upwelling phase of the Kelvin wave cycle, and we'll get into that in a second. But basically, you get a warm push, then a cool push, and a warm push, and a cool push, versus La Nina, where it's just constantly cold. So, yes, small Kelvin wave in development, pushing to the west. And here is another version of that. Same deal, cool water off of Ecuador. Here's our Kelvin wave. And we know western anomalies are blowing hard here, and we see this little finger of warm water starting to fall out of the maritime continent into the far west Pacific, and another bubble of warm water starting to build here. Now, this would be Kelvin wave number 3 for the year, and that maybe this is number 4. Hard to tell. Maybe they'll merge. Who knows what's going to happen? But what we do see is plenty of warm water pushing off to the east, and that's way better than cool water. Sea level anomalies. So there's South America. There's New Guinea there. There's your equator. There's the date line. This is from the Jason 2 or Jason 3 satellite. Just strip out all the waves, strip out the wind waves, strip out the tides. What we're looking for is a bump on the ocean surface, because that means that there's warm water down below. Warm water expands, of course, creates a little bump on the ocean surface. And we see that 5-centimeter bump, even 0 to 5 centimeters, basically over the entire equatorial Pacific, other than this one little pocket here near the Galapagos. So another Kelvin wave in flight and working its way off to the east, just confirming what we've seen in all the other data. And then here's a historical way to look at it. Last year, March 2018, this is the West Pacific here, East Pacific here. Temperatures, reds are hot, blues are cold. This was the last of our La Nina off of Ecuador last March, and here was the first Kelvin wave building, pushed into the coast there, into Central America on the June-July timeframe. Then there's a little cool push. There's that pocket again, right? Upwelling phase of the Kelvin wave cycle. Kelvin wave number 2, stronger, bigger, in the fall, made its way the whole way across. Here's the upwelling phase of the Kelvin wave cycle. Here's Kelvin wave number 3 working its way across. And we're hopeful that there'll be a Kelvin wave number 4 as well. So what's the effect of these Kelvin waves on the ocean surface? All right, so this is sea surface temperatures and anomalies, satellite-based, pretty detailed, really detailed, in fact. Anyway, you see the reds are warmer than normal. Differences from normal for this time of year. Pretty cooking warm, not super cooking, but warm off of Peru. If you were going to have El Nino, this area right in here is where you want to see the heat signature. And we're seeing that. There's this little pocket of cool water that's been here, but that's kind of interesting. Not sure where that's coming from. It seems like north winds just limited right to this area, causing upwelling. But here, generally warm. The main El Nino monitoring region is out here from 120 west out to 170 west, 5 degrees north and south of the equator. And it's warm there, not particularly warm, just barely. But typically what happens, Kelvin waves come rolling subsurface. They smack into the coast here. They upwell to the surface, and then the trades take that warm water and push it over into what they call the Nino 3.4 region right here. And then that is what starts causing evaporation. Evaporation starts feeding the jet stream and creates more precipitation than normal here. And then that starts changing the global atmospheric circulation, because normally waters are cooler than normal here, and you have strong high pressure and you don't get any rain. And when you all start getting rain in basically desert regions over here and out to sea here, that's a big, literally, it shifts the global circulation, and that is the hallmark of El Nino. Temperature trend for the past week, yep, getting warmer over this whole area. And it's actually got that kind of triangle signature now, which almost makes you think, I wonder if El Nino is going. Maybe, don't know. But it's kind of, at least for the moment, looking that way. I mean, if we have to wait, let's say 2 more months, and if we see this and it's stronger and building, then that's a sure sign. But we're not there yet. The overview pattern, starting to look a little bit more like that as well. So there's these cool anomalies here, but they've been really, you can actually look in here. They're losing ground, losing territory, and when this is gone, we think we'll be in a lot better position. And when you can get that straight triangle thing going here, then that's sort of El Nino. We're kind of looking like it, but it's only February. So the question is this the total peak warming from 2018's push of El Nino, or is this the beginning of something more substantial for 2019? Unknown, too early to know. That's why we do this every week, and we look and we watch, and you just see how the trends change. Sea surface temperature trend or data in the Nino 1.2 region. So this is right up along Peru and the Galapagos in that area. Today, we're 3.392, 0.4 of a degree above normal. What's the trend been, though? Kind of looks like it's been trending down, not up, and you want to see it go up. You want to see warm water building along the coast there, not fading. In the official El Nino monitoring region, the Nino 3.4 region from 120 west out to 170 west, 5 degrees north and south of the equator, we're at 0.443 today. And if you just sort of eyeball this, yeah, maybe the trend is down a little bit, but it almost seems like maybe it's stabilizing. So El Nino is 5 months at half a degree or greater in the Nino 3.4 region. So here's the monthly anomalies in the Nino 3.4 region. You know, those other one was daily. That's a little bit too noisy. So we're looking for, and here's the last month reported was January, of course, because we're still in February, but we've got 0.8 of a degree, 0.84, 0.86. So 1, 2, 3, 4 months above half a degree. You can actually see back in early 2018, here was our La Nina, minus 0.8. You know, you get it. 1, 2, 3, 4, 5, 6, 7 months below a half degree. And then just for fun, here was the El Nino of 2015. You want to talk about real El Ninos? Okay, 1 degree above normal, 1.25, 1.4, 1.8, 2. You get the idea. Cooking warm waters, peaking in the December-January time frame, very warm. That's El Nino. This is not, but it's sort of a weak Madoki like El Nino, if you want to call it that. All right, you get the idea. Okay, and now so we've talked the MJO and its contribution, and westerly wind bursts, their contributions to El Nino. We've talked subsurface temperature anomalies. We talked surface temperature anomalies, but there's also an atmospheric component. All this stuff has to go in play to really get you a legit real El Nino. So this is the atmospheric component data we're talking about. Difference in pressure between Darwin, Australia, and Tahiti. When Tahiti has lower pressure, that means basically lower pressure in the Pacific, sort of like that low pressure bias thing going on the dateline thing. That means that El Nino is developing. All right, so there's a daily index. Today's daily value, minus 19.36. So when the Tahiti, or when the index is negative, that means there's low pressure over Tahiti. The more negative, the better. We were at minus 43.61 a couple of days ago. So this is basically, and you can sort of look back here and just look up. It started going negative back February 7th and really bottomed out a couple of days ago. Now it's starting to retreat. So this is basically measuring the active phase of the MJO, not El Nino, active phase. And then it's kind of noisy, so you strip out the noise. A 30-day average, you can see it too is plummeting down at minus 11.26, which is pretty good. So then for measuring El Nino, you can use the 90-day average. And you can see we're going to actually go back. It's been hovering around 3. And now, given all this, it's down to minus 1. For this to be for the 90-day average to indicate El Nino, you need to be down around minus 10. So we have a long, long ways to go till we get there. But you can see the trend here on the graph. The dotted line here is the 90-day average. So 0 is right there, and we're just barely under 0. And this is we'll call it the MJO measuring index, suggesting, yeah, we're way down at, minus 11.26, but that's more an indicator of the MJO than El Nino. And the one other atmospheric indicator we have is the ESPI index. Instead of difference in pressure, it's the difference in rainfall between this square, north of Darwin, and this square over, the Nino 3.4 region. No big surprise there. And the index today, thank goodness, is actually positive, meaning there's more rainfall over here than normal. And it's 0.52. This is the highest it's been in 2 years or 3 years, or maybe since that last El Nino. Now, it's not really high, you know. We want to see it's probably up about 1 or something like that. But at least it's moving in the right direction. And you can kind of look here and you can see, yeah, it looks like more rainfall than normal. The blues are more, though it's still focused on the dateline. We really want to see it like over in here. But typically you wouldn't see that until maybe the fall of this year. We'll see it here, but we at least have some greens and blues starting to pop up. This suggests that for sure La Nina is finally dead in the atmosphere, because we've had suppressed precipitation here for, you know, a couple of years now. Finally, we're getting back into a semi-normal sort of pattern. So it's taken all this just to get us to the point where La Nina is dead and we're normal now. So this is actually a good sign. We're encouraged. And then finally, the forecast, the official sea surface temperature forecast from the CFS version 2 model for the Nino 3.4 region. Now this model, let's be clear, it's been grossly overhyping all this year what temperatures were supposed to be, but here it's showing it. The whole fall was 0.75, let's say, on average, which is about what we saw in the official other indexes. But it was hyping like up at 1.25. But the interesting part here is the model suggests we're certainly not crashing to La Nina. If anything, as we get into the spring, maybe associated with westerly wind bursts that the CFS forecast is talking about, and the fading of the MJO and the deepening of the low-pressure bias on the dateline. You get the drill, that maybe El Nino will build with temperatures in April, maybe 1.2 degrees above normal, and building to 1.5 into the fall and holding. And this is just a recent development here in the past week or so. I don't even recall last week it being this high. So the model, at least for the moment, is suggesting a warming pattern, not looking at these absolute values. I'd almost cut this in half and say, okay, maybe 0.75 to 1 degree. In this time frame, but that would be El Nino for sure. So we'll just have to wait and see. But the good news is the trend, all the data is pushing in the right direction instead of in the wrong direction. So we have something to look forward to and something to be hopeful for. All right, so that's our forecast for this week. We have a solid storm forecast for the dateline, swell to be produced, pushing towards Hawaii and the U.S. West Coast, and that storm is supposed to be developing in the next 2 days, let's say 2 to 3 days. Bad news is a bit of weather, both for Hawaii and the U.S. West Coast, coinciding with the arrival of the swell. So maybe if you got some protected nooks and crannies, you'll get some surf out of it. Otherwise, make the best of what you can get. Still some weather for California forecast. Rain, not piles of it, mainly limited to Northern California. So let's say draw a line from Monterey Bay northward and up into the Pacific Northwest. Long term, MJO, very solid. Supposed to fade out a little bit. We'll get the jet stream will split and things won't be so good for a couple weeks. But then a longer term, better looking pattern is forecast as we get into the end of March and April, and it only looks upwards from there. All right, so that's it for this week. We'll do it again next week on Sunday. We'll say same time, same channel on Sunday. Back to the regular pattern. All right, thanks for watching. Goodbye.